Hello fortune cookies, success stories! You're asking yourselves probably at this point, what is this video and am I doing enough to succeed in life? And the answer is yes you are, you're solving algorithmical problems and that's the path to success, my friends. The first step being opening a video, starting it. Well, you cannot always finish it. I know, it's long, it's boring, it's tedious. The guy is speaking in some monotonous Eastern European accent. Doesn't matter. Keep doing it. Success means persistence. Alright, let's solve a problem. Leetcode problem 1680. Concatenation of consecutive binary numbers. Given an integer n, return the decimal value of the binary string formed by concatenating the binary representations of 1 to n in order, modulo infinity, modulo 10 to the 9th plus 7, some super big prime number. Why I want to show you the solution of this problem? I find it a very good example of a bit manipulation problem. You can think of it in different ways, but if you think of it as a bit manipulation problem, the solution flows somewhat logically. And so you can think of this problem this way. We're having 1 at the beginning. We shift it to the left, and then we add 2. We shift them to the left, and then we add 3. We shift them to the left, and then we add 4, and so on until we reach n. It's really easy to think of it as bit shifting operation. You can always use multiplication by 2 to the power of whatever, but it's way simpler to visualize it if you think of it as bit shifting. And the length to which you need to shift every number depends on the number that you will be appending at the end. In the very beginning, you will shift 2 positions so that there is space to add the number 2 in binary. Then you will shift these 3 bits 2 more to leave space for the number 3, which is again expressed with 2 bits in binary. Then you will shift all those concatenated bits 3 spaces so that you can add the number 4, which is expressed with 3 bits, and so on. The space you need to shift to the left is equal to the number of bits of the next coming number. And this is a solution that does exactly that. Start with 0 and then we will shift left this result with the length of the next number, and then we will add this next number to the end. And then we apply this modulo infinity operation. By the way, I don't know if you know, but in Java you can add underscores for readability, like so. Yeah, and so the idea here is you shift the existing result and then you add to the end of it the next number. Adding to the end of it is actually equal to this in this case, because the final bits of the shifted number will always be zeros, and so you can use bitwise OR to add the next number. This can be a one-liner here. We can do it a one-liner like so. And that's a valid solution that solves the problem. However, there is a little trick that you can apply. If you think about it, the length of the next number is kind of predictable. For 1, that would be 1 bit. For 2 and 3, that would be 2 bits, right? For 4, that would be 3 bits, and so it will be for 5. And for 6 and for 7 you will have 0, 1, 2, 0, 0. And then for 8 it will become 4. If you notice the pattern here, the moment you reach a degree of 2, the bits increase by 1, the number of bits in the number in binary representation. And so what you can do here, instead of using this Java method to extract the length of the binary string, to improve on the performance of this problem and remove this expensive operation in every loop, replace it with a constant operation. What you can do is you can have this variable length, and every time you reach a power of 2, which you can do like so, and that's a neat hack key. way of checking whether I is a power of 2. Every time you reach this border number, you can increment the length of the next number by 1. And now we only need to do this. And we need some braces. That improves a lot the runtime. And here it is. We're at the end of our short trip through algorithm land. It's a simple problem, but it demonstrates well the importance of bit manipulation. There are problems that lend themselves to way easier solutions if you look at them through the prism, through the perspective of bit manipulation. Couple of things to pay attention to. You can use bitwise OR instead of addition when the bits of the numbers are not overlapping. In other words, you know that all the ones in one number are where in the other numbers you have zeros. Then instead of adding, you can use OR. The second trick is you can use shift instead of multiplication by 2. So instead of multiplying length times by 2, this result, we shifted it to the left by length. And the last trick here is you can use this, the number bitwise and the number -1, which means 8 and 7, for example. 8 and 7 would give you 0 in the cases where the number is a power of 2. Let me know what you think. Is this a problem that you would find difficult, you would trip upon if you get it on an interview? I personally know that bit manipulation problems are outside of my strongest domains, so sometimes they trip me on interviews. It's good to practice those. This specific problem has been given at Amazon 1 to 2 years ago. That was it. Is this as easy as multiplying 7 by 17 or whatever is your idea of basic math operations? Or is it as difficult as finding happiness in life? Where are we on the difficulty scale from 1 to 10 to the power of 9 plus 7? Let me know. You better let me know. I'll know if you don't let me know. See ya. See ya. Yes, come in. See ya. Cheerios and see ya. Peace.